Hello viewer, welcome back. We have discussed about event sourcing architecture and its principles in my previous video. If you haven't watched my previous video, please check on the link showing above, or you can find the link in the description. In this video, we are going to discuss about what is CQRS and how CQRS architecture pattern supports the event sourcing architecture pattern, and how these both architecture patterns complement each other to build an efficient event-driven system. So stay tuned until the end of this video. CQRS means Command Query Responsibility Segregation. In CQRS pattern, commands are write operations and queries are read operations. So we can separate the components that do the write operations and components do the read operations. So in this way, we can increase the performance of the application. If you see our old school entire architecture, we are doing all read operations and write operations using single stack of components. When it comes to CQRS, we can do like this. So we have separated the command endpoint and query endpoint, and also service, command service and query service, and even we have separate data access object layers. For example, if you see any service in our classical interface or service interface, we have save order, update order, which are write operations, and get order by date and get order by ID. These are read operations. So if you want to refactor your classical service interface into CQRS style interface, that will be like this. So we have command service and query service. The command service obviously will have the write operations methods, and query service will have the read operations. But one problem we have here, if you see our whole entire architecture, we have single RDBMS, and also even when it comes to CQRS, in the diagram on the architecture that is showing on the screen will have one drawback. Still, the command components and query components are using single data store. So we can refactor this into like this. By combining event sourcing and CQRS architecture patterns and principles, we'll have the final architecture like this. If you see the left side, we have the command component, on the right side we have the query components. So we have event store in command side components. So always the command service issues the events to the event store. So event store always stores the events from command components, and also we have the event handler, which always listens to the event store. So each and every event that is stored on event store, that will be synchronized to the read storage. So, and also we have the query components always reads the data or events from read storage. It never reads data from event store. And also we can have the separate data model for our query component as well as command components. For example, if your business domain is like a graph oriented, you can use Neo4j as your read storage. And if your business domain is like a search oriented or search engine, then you can use Elasticsearch as your read storage. The substantial advantage in this particular architecture is you have the separate components for read and write operations, and also we have separate data store for writing and for reading. Let's look into the advantages of this combination of event sourcing and CQRS patterns. We can scale up and scale down read components and write components very easily. Because if your application is doing more write operations, we can scale up the only write components and based on your requirement. For example, if you take any bank, it does a lot of operations, write operations at the end of the day. So in that case, if your application is running on AWS or any other cloud, you can easily scale up at that particular moment to do the more write operations, and later once the write operations job done, you can scale down easily that particular job. So in that way, you can scale out and scale down your application based on your write and read operations capability. And you have the choice of choosing technologies. Of course, as a developer, we would like to choose and work on latest technologies, but Yeah, you can choose different technology for write component, and also you can choose different programming language for your read component as well. But be wise while choosing the technology. Don't go with multiple programming languages and multiple technologies, so that it will be difficult for you to manage. And also it greatly fits into the idea of domain driven design. We can define business contexts for these microservices. These contexts can be bound to an aggregate level, and context might also include data aggregates. This increases microservices granularity. If you see the first point, like individual scalability and deployment options, here actually it fits into the microservices architecture, because we have separate component for read operations and write operations. So these are the main three advantages if you are using event sourcing and CQRS architecture patterns to build your event driven applications. So if you have any other advantages you found while this discussion, please put them in comment section. Of course, when you are building your applications using CQRS and event sourcing architecture patterns, you definitely have some challenges while building your application. That is with respect to consistency. So what is the consistency level that your system will have when you follow the CQRS and event sourcing patterns? And validation, how you can do the validation of your data or events, and parallel updates. Let's discuss about consistency first. So any system that is based on CQRS or event sourcing are mostly eventually consistent. No any other distributed system is fully consistent in the world. It's definitely eventually consistent. When you look at this architecture diagram you are seeing here, when you are writing events to the event store, we have the consistency risk here. Eventual consistency can occur while storing the events to the event store. If the writing operation is asynchronous, and if it is a fire and forget process, then there is no guarantee that event is ended up in the event store. And there is consistency risk at event handler as well. If the event handler don't update an event from event store to the read storage immediately, then there is a risk. So if you decide to update events to read storage with 1 or 5 minutes latency, then it also eventual consistency. And also consistency risk at while updating the events to the read storage. This also depends on how transactional the updates are. Again, the consistency depends on what kind of technology the read storage is. For instance, if you use highly distributed in-memory data grid, how consistent updates to other nodes. If you know CAP theorem, CAP, that is consistency, availability, and partition tolerance. You can have only two of them. If you favor availability, certainly you need to have the partition tolerance as well. If you favor consistency, you have to adjust the system that can derive with good consistency level. If you favor availability, you have so many choices, like how much you want to limit the consistency guarantee in the system. By following event sourcing principles, you can build a very good consistent system. It is almost fully consistent, but not 100% fully consistent. We can build a system like this. We can have relational database as event store and read storage running on a same node. We can have a single transaction from event handler that will do the event inserts to event store and updates the read storage in a single transaction. Then we can have idea of event system, that is event driven system with events on event storage, and the idea of read storage. Then we have high transactional guarantee. If you see, is this system is very good in scaling and availability? Definitely no. Actually, the event driven system or domain driven system says that we should consider business domain to decide what level of consistency the system should have, not the technology. And also consider the business value, how much it hurts your business, how much it hurts the organization for failed transactions. Consider business domain and business value to decide the level of consistency in the system that is suitable for your business domain. Always inspect your business requirements and your business value. So the business domain decides the level of consistency in the system, not any technology that you are interested in. To increase the consistency level, you can do some adjustments in your architecture like this. Make event store as extremely transactional. The left side part is highly consistent here, and read store side we can do the updates asynchronously, and we can live with the data that is updated with 5 to 10 minutes latency. It depends on the data or business domain you have. The best example is the countries list. Countries list is not updated very frequently unless there is a new country formed or maybe the existing country is disappeared. This is very rare case that happens. Even if there is no problem if this kind of problem occurs, and even we can live with there is no sync between event store and read storage at least some hours, even some days. So there is no any problem. So it doesn't hurt our business domain. When it comes to like a system like stock trading system, if there is a 5 to 10 minutes latency while updating the events from event store to read storage, that is very dangerous to business domain. So you cannot live with that data. This kind of systems cannot tolerate the latency in between event store and read storage. There is no standard solution actually, so we should always inspect our business domain. That's what domain driven design says. What kind of technology we have to use for read storage? We can use RDBMS or graph database if your business domain is a graph oriented domain. So we can use Neo4j. And if it is if our business domain or your system is mostly depending on querying the data like with the data which has a key value pair, so you can use Redis as your storage. And if your application is more into search oriented domain, so you can use Elasticsearch as your read storage. So it completely depends on a business domain. So let's business domain always decides the level of consistency in your system, not any technology or fancy thing like whatever the team members interested in. So far we have discussed about consistency, and what about now validation? So how we should validate the data or events in your read storage or in event store. For example, if you want to validate the data like credit card number and what is the max and minimum value in the credit card number, or maybe the customer address, it's very easy. So you can validate this kind of data in your business logic and you can go ahead. But the interesting part is the uniqueness of the data. So there we have a problem. We should do it properly. For example, if you see that in a user having data like user ID, email and password, and if the user wants to register himself into the system, so we have the register user command, and once the user is registered in your database or event store, user registered event will be registered or inserted into your event store. If the user wants to change his email ID, so he can easily change, like once the email is changed, that email changed event will be registered in your event store. Here if your business domain says that email ID should be unique in your event store, then we should take care of proper validation, how you should validate your email ID. For example, for instance, whenever the system is trying to register the new customer or new user with his email ID, it has to validate the data against the event store or read storage, whether this particular email ID is already exist. So if it is exist, it doesn't accept the user registration and tells the user this email ID is already exist. But what happens, for example, user registered event is stored in event store, but it is not updated into the read storage, and when the new user is trying to register himself with the same email ID and the validation is happening against the read storage, still the read storage doesn't get the update from the event store, then there is a problem. In this scenario, we ended up with two events that is stored in event store with same email ID. So how we should tackle this kind of scenario? That's what we have to think about, how this kind of transaction failures can hurt your business. So we have to look into our business domain. What is the business loss because of this failed transaction? So this is how much it hurts. So in that case, you can organize the things like whenever you found two events with the same email ID they're trying to register, so you can tell the customer care, so there is some issue in the system and why can't you use this particular event and incident, and tells the particular user that he has some problem with email ID and why can't he try with another new email ID. In that way we can organize the things and we can solve the issue. So it is very simple. So that's the reason whenever if you want to do specific validations with your events, it's always look into your business domain. So in that way we can solve, as I said, like by organizing the things, and you can solve the issues. But if it is really, it hurts a lot your business, then definitely you should take the proper measurements to tackle this issue technically, and you do the proper changes in your code or business logic to validate the uniqueness of your email IDs or any specific data. So that's what, how high is probability that a validation fails. So which data is required for the validation, and where is the data is stored, whether it is in a read store or an event store. So we should consider, so to validate the data we have to consider the event store or read storage. What is the business impact of failed validation that is not recognized due to eventual consistency? So in all these factors are very important while validating the data. Always look into your business domain to do any consistency level or MIB validation, how you should validate the data in your system. Validate data from event store, that is also possible, but there is a problem when you are trying to read the data from event store when you are trying to validate the new user registration, because it's very bad in performance wise. So it's always good to have validation by reading the read storage always. So this is the preferred choice for any organization or any system. So always look into the read storage and validate the data. Perform validation event handler. Of course, you can do the validation in event handler with some business logic implementation, reading the data from event store or might be from read storage. How to deal with parallel updates? We have the same user domain that has user ID, email, and password. For example, what happens if Peter and Lisa share the same account and they both try to update the password at the same time? This is the scenario. Before we get into how we use it to solve this in our old school architecture, we were doing pessimistic locking or optimistic locking on datasets. The dataset is locked for that specific transaction, and we do update command and so on. Version incrementation with every update of command, or timestamp mechanism with optimistic locking. If something goes wrong, we throw an error message back to the user saying that it's something already the change is happened, and we use it to send the message back to the user. Again, the locking quality should be decided by the business domain. Pessimistic locking on dataset is hardly works on event sourcing architectures. What do we do pessimistically lock on event store or read store? It won't work at all. Pessimistic locking is a bad practice even in our old school architecture. We don't prefer pessimistic locking in our, if we really want to do pessimistic locking in our event sourcing architecture, we can do it on business logic level. We can issue a user logged event to event store and gets replicated very fast to the read store. So in that way we can lock the specific transaction and we can stop the going further. So this is actually not a pessimistic locking, basically it's business lock. Like this we can solve an issue. Pessimistic lock has so many issues in our old school architecture as well. With optimistic locking always working fine, and we can easily find the collision of the same kind of transactions or parallel updates, and we use to send back an error message to the user saying that this particular transaction is already updated, please refresh the page and try to give the new request. In that way we use it to solve the issues in our old school architecture as well, and this is also an organizational activity to solve the issue. The optimistic locking was always working in our old school architecture, and we also prefer to do the optimistic locking in event sourcing and CQRS architecture patterns as well. By introducing a new field like version, and we can do the proper optimistic locking on our data sets. See, for example, if the Peter and Lisa, they are trying to update the email ID in the system, so they just try to, any user can register the event with the user ID and version as a 0 always in the first event, and the old email ID and password. So whenever the new request comes for change, the email changed event will try to request with version 0, and it always try to look at what is the version of the existing event in the system. So it's always checks, always there is a new version. So incremental version, if there is a 0 version, then it go ahead, and if the another email changed event, so we have the old version 1, and if the new request comes with user ID 10 and version is 2, then it is always good. But if again the email change event version 1, and we should tell that we should always check the existing system email change failed event. We have to create email change failed event. In this way, we can do the proper optimistic locking on the data sets. So always your business domain is the final decision maker about your consistency and validation and parallel updates. So always check with your business people how it hurts the business value, like how much it will cost if something happens, something failure happens in the system. So if there is something like sending a mail back to the user, like email change or something, that is fine, we can live with that. But if something, we should always consider our business domain to validate our data, or to deal with your consistency level, or deal with the parallel updates. Always check with your business domain, and you can solve your issues in your system or in your business domain. That's all, guys. This is what I want to explain about CQRS and event sourcing architecture patterns in this video. I hope this video is very interesting and you have learned a lot of things about CQRS architecture pattern and also event sourcing architecture patterns. So these are very useful architecture patterns to follow or to build your event-driven system in your organization. So event sourcing and CQRS architecture patterns complement each other to build a very efficient event-driven system for your organization. So if you like this video, like it, and if you are new here on my channel, subscribe to the channel, and don't forget to press the bell icon so that you don't miss my future videos. See you in the next video. Until then, goodbye.